Today we're going to talk about composition of functions, and in fact we're going to be working with functions today and tomorrow and Wednesday. So we'll have a lot of chance to get a lot of practice on them. But what composition of functions is that we're working with more than one function at a time. And what we talked about last week is we talked about input values, which were the domain values and also the x values, and we called them the independent variables. And then once we decided what our independent variable was, our y value, our range, depended on whatever we put into the function for x. So it makes sense that we can do things with the output value, like use it in an input value in another function. And this process is called the composition of functions. There's two different notations. There is g parentheses f of x, or there's g open circle f of x. But remember, neither one of those means multiply. These are read g of f of x. Whether it's parentheses or this open circle, it's g of f of x. And what's happening is we're going to put a value into a function, then we'll get something out of it, and what we get out of it, then we're going to put into another function to get our final output. Sometimes it's better seen with an example than maybe with a chart there. So our first function here, we're given, or our first example is given f of x equals x plus 7 and g of x equals x squared minus 4. What we want to find is we want to find f of g of 2. We're going to start farthest to the right in this problem, which sometimes is read as inside out. But what we're going to start with is we're going to figure out, well, what does g of 2 equal? Well, what I like to do is I like to write down our function g, and our function g says x squared minus 4. And now what we're going to do is we're going to take this value of 2, and we're going to put it into the function wherever we see x. So this is going to become 2 squared minus 4. 2 squared means 2 times 2. So we have 4 minus 4, which equals 0. That's our output when we put 2 into the function. But now what we're going to do is we're going to use that output in another function. Now we're going to figure out, well, what does f, because we did the g already, what does f of 0 equal? Again, I like to write down what my function that I'm working with is, which is x plus 7. And we're going to take that value of 0, and we're going to put it back in here for x. So this is going to be 0 plus 7, and 0 plus 7 is 7. And this value of 7 is our final output. You do not need to write final output there. Now on this topic, sometimes the first example you go, I have no idea what she did. And the second example, you might be saying the same. Usually around the third example, you go, oh yeah, this isn't that bad. Sometimes it looks weird, and maybe it does. Well, let's try another one. I think I went a little bit quick on that one. I'll try to slow down. So in example number 2, we're given 3 functions. We have an f of x, we have a g of x, and an h of x. And we don't necessarily need to use all 3 of them. In this case, on 2a here, we are going to figure out what does g of negative 2 equal. Notice that's farthest to the right, or it's the inside of the function. Once we get the answer to g of -2, we're going to use that answer, that output, as an input back into f. So g of -2 is what we're going to figure out. Our g function, as we look up there, is 9x minus 1. We're going to take this value of -2. We put it back into our function wherever we see x. So it's going to be 9 times -2 minus 1. 9 times -2 is -18 minus 1. And -18 minus 1 is -19. We put -2 into the function, we get out -19. And now what's going to happen is we're going to take our output and make it the input for our f function. So now we're going to put -19 into our f function, which is x squared plus 5. And -19 is going to go back in here for x. Be careful if you're typing it into your calculator. You need parentheses if you're going to put it into your calculator. -19 squared means -19 times -19, which is 361 plus 5. 361 plus 5 is 366. That's our final output. And for some of you, you're like, oh yeah, I got this. And some of you are thinking, yeah, I still don't know what we're doing. And that's okay. Let's look at another example. Still given the same functions. Our f function, our g function, our h function. Here's different notation. This is h open circle g of -3. H of g of -3, we want to start farthest to the right or inside out. We want to figure out, first of all, what does g of -3 equal? And our g function is 9x minus 1. We're going to take this value of -3 and we're going to replace our x. Any x value. If we had more than one, we would replace all of the x values with that value of -3. So this is 9 times -3 minus 1. And 9 times -3 is -27 minus 1, which is -28. We put -3 into the function, we get out -28. Now we're going to take that value of -28 and we're going to put it back into our h function. And our h function is -2x. We are going to replace the x value with this value of -28. So it's -2 times -28. And that will give us our final output of 56. So example C, we see a fraction, and don't be afraid of the fractions. We still have our same functions, f and g and h, and we're going to start with our h of 1/2. Start farther to the right or on the inside out. H of 1/2. Our h function is negative 2x. We're going to take this value of 1/2, and we're going to put it back in here for x. So it's going to be negative 2 times 1/2. And again, I know some of you say, well, I don't have a calculator, but what's half of 2? 1. And then it's negative times positive, so this is negative 1. So when we put 1/2 into the function, we get negative 1 out. And now we're going to take that value of negative 1 and we're going to go back into our f function to help us get our final output. So it's f of 1, which is x squared plus 5. We're going to put that value of negative 1 back in here for x. So it's negative 1 squared from color plus 5. And once again, if you do have to type that in your calculator, remember that negative 1 squared means negative 1 times negative 1. Negative times negative is positive. And 1 plus 5 then gives us our final output of 6. Letter G. This time we are going to use all of our functions. F and G and H. We're actually going to start farthest to the right by the H. We're going to figure out, well, what's H of 2? Then we're going to get our output. That output then is we're going to use back in our G. We're going to get another output. And once we get that output, we're going to put it back into our function F to get our final output. So at first, let's figure out the H of 2. So our H function is negative 2x. We're going to take this value of 2 and we're going to put it back in here for x. So we get negative 2 times 2, which is negative 4. There's our output when we put 2 in. We are going to use that value of negative 4, and we're going to now figure out the G. So we're moving essentially from right to left in terms of the functions that we're using. It's going to be G of negative 4, and our G function is 9x minus 1. We're going to take that value of negative 4 and put it back in. So it's 9 times negative 4 minus 1. 9 times negative 4 is negative 36 minus 1. And negative 36 minus 1 is negative 37. So now we're going to take that output. We're going to go through these motions one more time. We're going to go back into our f function, which is x squared plus 5. Let's take that negative 37 and put it back in for our x. We need to be careful. If you're using a calculator, you must have parentheses around that. It's going to be negative 37 squared plus 5. That means negative 37 times negative 37. just as an aside. So when we type that in, I believe we get 1,369 plus 5, which is 1,374, which is our final output. So as we flip the paper over here, we've been working with functions, and last week we talked about functions as a set of order pairs. We looked at charts or tables, we looked at graphs, and as we turn our paper over, we have some graphs here. And our first graph here is our f of x graph. Our second graph is g of x, and we're going to use them to help us evaluate our compositions. And again, we still start right, farthest to the right or inside out. So in our first situation, we want to figure out, well, what does f of 2 equal? And we look up here and we see f of 2, which is 1, 2, 3. That gives us 3. Well, we just figured out that f of 2 is 3. Now we're going to take that value of 3, that was the output from the original, and make it the input now. We're going to look at the other graph here, our g of x graph, and we're going to go to g of 3. 1, 2, 3. Well, then our output becomes 1, 2, 3. G of 3 just so happens to be 3. So it should be a real quick process. I know sometimes what people do is they just write this. On our next one, we're starting with g of negative 1. So we're going to start over here on this graph, the graph farthest to the right. G of negative 1 gives us 1, 2, 3, 4, 5 negative. And then what we have to do is we have to take that output and make it an input for our f. Well, 1, 2, 3, 4, 5 is this value here, and it looks like -0.5. Sometimes that's the way people write their answers. Not my favorite way, but I get it. When we looked at letter C, notice that we can use the same function more than once. G of 1. G of 1. And come up here. G of 1 is 3. Well, we figured out that value. Now what we want to figure out, well, what does G of 3 equal? So we're going to stay on that same graph. G of 3, 1, 2, 3, 1, 2, 3. We already actually did that back there in example A. And to finish, G of f of negative 2. Again, there's that open circle. It does not mean multiply. We're going to figure out, first of all, what does f of negative 2 equal. So we're going to go to the graph that's to the left on our paper. F of negative 2 equals 1. So there's our output, but now that output is going to become an input in our g function. G of 1 is 3. Over 1, 1, 2, 3. As we look at letter E. F of G of 0. We're going to start with G of 0. We start farthest to the right, inside out. G of 0. Well, G of 0 is 0. That output of 0 now is going to become the input back into our f function. F of 0 is 2. And to finish, f of 0, again, we can use the same graph more than once. F of 0, so f of 0 is 2. We actually just did that one as well. So that value of 2 now becomes the output. Now becomes the input. It was the output, now it's the input. F of 2 gives us 3.